All right, let's talk about making AI models smaller and faster. We always hear about what to cut out, right? Which neurons, which layers. But what if I told you the real secret, the thing that changes everything, isn't about what you prune, but when you do it?
So here's our game plan. We're going to start with why timing is such a big deal in the first place. Then we'll look at the two big ways people do this: pruning during training versus pruning after. We'll compare them head-to-head, talk about what you got to do after you've made the cuts, and wrap up with the really cool questions that researchers are still trying to figure out.
Okay, let's kick things off with the big one, the pruning timing problem. Before we get into any of the how-to stuff, we really need to get why this is such a fundamental issue to begin with. So it all boils down to this, right? When is the best time to actually prune a massive AI model? I mean, it sounds like such a simple question. But believe me, the answer changes everything for anyone who's actually building or using these things. Do you trim the fat while the model is still a baby, still learning? Or do you wait until it's a fully formed adult?
And here's the kicker. For a long time, most researchers kind of just assumed, the timing probably doesn't matter that much. It was seen as just a minor detail. But what we're finding out is that, in practice, it determines, well, pretty much everything. It's not a detail, it's the whole ballgame.
And I'm not talking about tiny tweaks here. This choice has this huge ripple effect across the board. I mean, it hits the stability of your final model. Like, will it just fall over when you show it something new? It totally dictates your compute cost. And we could be talking about the difference between a few $1,000s and a few million. Obviously, it affects the final performance and accuracy. And, maybe most importantly, it determines if your approach can even scale to the beastly billion-parameter models we're all working with now. So yeah, this is a major strategic call, not some little technical knob to turn.
Okay, so let's check out the first major fork in the road. Path 1, pruning during pre-training. The best way to think about this is like you're a sculptor, you've got this giant block of marble, and instead of carving the whole statue at the end, you're chipping away and shaping it as you go, right from the very start.
So how does that actually work? Well, the pipeline is pretty straightforward on paper. You start training your big model, but you only go part of the way. Then you hit pause. You run some tests to figure out which neurons are kind of slacking off, not really pulling their weight. You snip out those least important parts, and then you press play again, continuing to train the new, smaller model. You're basically guiding its development from a very young age.
Now, when this approach works, it's beautiful. You can get a really elegant and efficient model. But there's a big but. The downsides are pretty serious. First off, it's wildly expensive. You still need the entire compute budget of a full pre-training run. Second, it's super sensitive. If you prune too early, too late, too much, the whole thing can fall apart. And that leads to the third problem. When things go wrong, good luck figuring out why. Debugging these failures is an absolute nightmare.
So, you might be asking, who on earth would do this? Well, the answer is pretty simple. The big guys. We're talking about the massive foundation model builders. They're the only ones who can really afford the huge costs and the risks, because for them, even a small efficiency gain at scale can save millions down the line. Which brings us to the other path, the one for the rest of us, post-training pruning. If pre-training pruning is like sculpting from scratch, this is more like taking a finished car, a Ferrari, let's say, and expertly tuning it to make it lighter and faster without losing any of its power.
And the process here is way more direct. You start with a fully trained, off-the-shelf model that you know already works well. You analyze it to find the parts that are redundant, then you do a single, clean prune to cut them out. And here's the really clever part. You use a super efficient technique like LoRA to quickly fine-tune the model and get back any performance you might have lost. It's fast, it's targeted, it's smart.
And just look at how effective this is. You can chop out 30 to 50% of the entire model. That's a massive deal for speed and cost. And the best part? After a quick recovery phase, the accuracy loss is less than 1%. I mean, think about that. Half the size, almost all of the smarts. That's a trade-off I'll take any day.
And this really just sums it all up, doesn't it? For pretty much everyone out there, most researchers, most developers, post-training pruning just gives you the best bang for your buck. You get fantastic results without needing a crazy budget. It's the practical, smart choice for getting things done.
All right, this is where the rubber meets the road. We've seen the two paths, now let's put them in the ring, side by side, and really break down the trade-offs on the stuff that actually matters when you're trying to ship a product.
I mean, just look at this breakdown. It couldn't be clearer. Compute cost, post-training is low, pre-training is through the roof, no contest. Stability, post-training is way more stable because you're starting with a model that's already solid. Task flexibility? Again, post-training wins because you can easily adapt the pruned model. And deployment speed? Getting your model into the hands of users? It's not even close. Post-training is just so much faster. On basically every practical level, it's a knockout.
Okay, so you've picked your path, you've pruned your model, it's smaller and faster. We're done, right? Well, not so fast. The story isn't over. What you do after the pruning is just as important as the pruning itself.
And this is a super important point that a lot of people miss. Pruning a model based on general knowledge, like stuff from Wikipedia, is totally different from pruning it for a very specific job. Imagine you're training a general-purpose athlete, and you decide their leg muscles for kicking aren't that important. That's fine, until you ask them to become a professional soccer player. The very parts you cut might be the exact ones you needed for your specific task. So, how do you fix this? How do you get that performance back? The key is to think like a surgeon, not a demolition crew. The data is clear. Small, targeted fixes work best. Things like LoRA or other adapters that only tweak tiny parts of the model. That's the surgical approach. What you don't want to do is the fire hose method of just trying to fully fine-tune the whole pruned model again. It's too much, it can destabilize everything. And obviously, the worst thing you can do is nothing at all.
And that brings us to the final part, which is always my favorite, the unanswered questions. Because in a field that's moving this fast, every new discovery just opens up a whole new set of fascinating puzzles for us to solve. So let's peek over the horizon a bit.
I mean, people are working on some seriously cool stuff. Like, if we prune a model when it's too young, do we accidentally kill off its potential to develop those amazing, emergent abilities we see? Could we just train another AI to figure out the perfect pruning plan for us? How does all this snipping and cutting affect the safety and alignment layers? And my personal favorite, this idea of lottery tickets. Could there be a tiny, perfect, super efficient network hidden inside a giant model, just waiting to be discovered for one specific task?
So if there is one single thing you remember from all of this, let it be this quote right here. Choosing when to prune is not just some small optimization you do at the end. It is a core modeling choice. It's a fundamental decision that shapes your entire project, your costs, your performance, your speed, it's everything.
And this all kind of leads to a final, bigger, more philosophical question to leave you with. We know these giant models have a lot of redundancy built in. So as we get better and better at this pruning thing, as we get better at finding these smaller, perfect little networks hiding inside the big ones, it makes you wonder, are we actually building artificial intelligence from the ground up, or are we just getting better at discovering the intelligence that was already lying dormant inside?